So I'm Jared Fuchs. I'm the CEO of Slamen Solutions. We're a 5-person startup based out of Huntsville. We started about 3 years ago. My background's actually in physics, so I was studying gamma ray bursts, getting my PhD at UAH. But by the time I was finishing my PhD up, I was running this CubeSat project, and we had partnerships with universities across the state, with like Goddard, and we were putting together mission proposals. Like every year, we're trying to put together a new concept. And we thought, well, digital engineering, right? That's the thing to do. That's going to make us work faster. We're going to make us work more efficiently, make better decisions. And so we got Cameo set up. And we started building these systems models. And turns out that didn't really make us faster. And it honestly didn't really make us better. It was just more difficult to do. And we ended up still sharing around Excel files and PowerPoints. And so that was pretty frustrating. And as I was working through this, I was like, well, there's got to be a better way to do this. And so we started looking at like ontology frameworks to kind of automate processes. And then eventually ChatGPT came out, and I had already seen transformers before, making these funny little statements, you know, and little poems and stuff online. But then when ChatGPT came out, it was like, okay, transformers have now evolved. And it was a huge breakthrough. We all know that's the turning point that's gotten us here. And so I thought, well, this kind of technology, surely if we put this inside the loop here, we can start to speed up all of these processes. Because when we think about design, and the topic of this presentation is about design, how can we get AI to go from I want a satellite to all of the data products we need, the requirements, the parts, the documents, the analysis, right? A good way to do that is to create these models. But those models take scale, right? There's so much data that we have to connect. There's so much data we have to write, all these codes, all these connections. Doing that manually is difficult enough. When you put another layer of certain tools that are hard to use, and I'll pick on Cameo, systems model if you've used that, if we can fix both the UI part and use these AI systems to move faster at connecting and creating that data, that's the only way we can really get through that curve. And right now, when you think of systems engineering and digital engineering, it ends up being a big cost factor, right? Because you've got to have specialized people. But AI can also lower that barrier of entry. And so that's kind of the vision that we had. I'm also joined here on stage by Ian. So I'm physics, but Ian actually knows a little more about MBSC if you want to give your background.
Yeah, I am Ian Slamen. I am the COO of Slamen Solutions. I have a background in aerospace and systems engineering. Went to UAH with Jared, got my undergrad there. Got my master's in systems engineering at George Washington University. Then was working at Collins Aerospace doing the defense contracting thing for a couple years. Then went to Georgia Tech Research Institute for a couple years, did a bit of the more academic defense contracting side of things. And during that whole time, I was getting a lot of experience on platforms that were using MBSE, next generation vertical lift platforms like Flora, right? Trying to do this new way of doing engineering. And the whole time it was a slog and a miserable experience. And once Jared came to me and was like, hey, I want to replace Cameo, I was like, dude, the moment you get money, bring me on. So now I'm here.
And we're happy to have you. So this is a QR code. This will take you to a website with DaVinci. DaVinci is the application that we're using to build this. This is a platform that combines that systems engineering aspect, that creating of these digital models with agents, right? So we're using commercial LLMs inside of an agent framework that we've built, and we're going to kind of explain how that works and show you. But if you want to use this QR code, it'll take you online. It'll be a sign-up thing where you'll put in an email and a password. You will be sent a code, and then you put that code into it, and then you can log in, and you can begin projects you want. And obviously, we'll be doing a live project now. So I'll hold this up for a few more seconds before we jump into building a project. And again, it will only work on a laptop or tablet and on a phone. Very sorry.
I'll observe. How do they scan the QR code with their computer?
They can't, but you can look at you can go to our website, Slamen Solutions. You can also try free. It's the same link there, but you can pull it up on your phone with the site, and then you can log in with your computer. All right, with that, Ian, let's go ahead and send over to our first workshop. So this is DaVinci. We're going to go ahead and start up a task. So we're going to do 2 examples. One of them is going to be modeling the Space Launch System. So for fun, we thought we're in Huntsville, right? It's a town of rockets. We're also going to be heading to see the Artemis II launch soon, so it seems fitting to talk about SLS. It's going to have a big milestone mission. So we're going to build a system model of that, and I'm going to walk you through kind of what that means. But first, we're going to get a task started. So this is the UX of DaVinci, and so like most systems, there's a chat element on the right here, so you're going to be interacting with a primary orchestration agent. There's a workspace in the middle This workspace is where you're going to look at the data it creates, and it's going to be creating these models, and I'll explain that in a moment. And on the left side here, these are the index of data objects. So with DaVinci, all you need to do is just begin by putting in a task. And so here, Ian started with a natural language prompt of build this SLS system, parts specifically, meaning a physical kind of structure. And now the agent is going through and thinking about things. So the agent thought about what this task means. It is now going to use a set of tools. I'm sure a lot of you have seen presentations throughout these few days about agents. One of the things that define an agent is that it's an LLM that has this context and it can call these tools. And so what we've done is we've hooked up this LLM to a set of different tools. We've loaded in as background information some PDF files. These are files about the system. So these are like 1-2 page kind of info about different elements of the system. So obviously if you had a full technical manual, you could provide that. But we just have these, and these are going to serve as kind of a basis to kind of guide the design. You, of course, could ask, as you can, any chat system, anything you want, and it could create that. But what this is going to do is this agent here, this is our main kind of orchestrator, it has access to a whole set of tools. These tools can then call maybe direct operations, like add a part, update its name, its documentation. But some of these tools, like build parts, actually sets up a series of sub-agents. So build parts can be a big task, right? You got to think about a hierarchy of systems. You got to put attributes for those systems, and you got to roll up those attributes. And so what this task does is it sets a series of instructions. Those instructions then go off into sub-agents. And so we can run some of those tasks in parallel, some in series. And so this isn't exactly an agent-to-agent per se, in that we don't have a whole separate agent with different authority. It's more of a manager operating a hierarchy of things. And so this is running a whole set of different sub-activities. Now, what is this agent doing? So we can switch over to a different pre-built project while this cooks. This task will take a few minutes to run, and if you've started one, I suggest think of a system you'd like, ask it to build a part structure of that, and it should return a result in a few minutes. So this is another example here, another space example. I worked on satellites, so that's why we did space examples. And so what the agent is fundamentally doing is not necessarily returning text like a ChatGPT would do. What it's instructed to do is actually build these data objects. So what build parts is doing is it's tasking the AI to actually create database objects. These database objects can form hierarchies. So this is a data object here. It has like a name description. It can own a set of other data objects, like attributes, other parts. Okay, so these form a schema. The schema we're using is a systems modeling language. If you're in the MBSC space, you've probably heard of that. This is the System LV2 spec. And that basically has a hierarchy of different objects, like a part, a requirement, an action. And they can have relationships between each other. So a part can be a subject of a requirement. And through that, you can form a graph database. Is everyone kind of familiar or heard concept of graph databases? Yeah. So the point of this is that the agent here builds these structured informations. Once that structured information is built, you have more codified information that has more specific relationships than just say text to text, right? So this isn't trying to transform, build a parts tree for a rocket into another document. It's creating a rigorous structure with attributes. These attributes, if you want to click on like the mass attribute in, can form equation trees. So each of the subsystems here can roll up. This is a pretty simple one, but it can be arbitrarily complicated. And so these equations here are what the AI is focused on. Now at the leaf element here, those might be sourced by like a reference document. They could be sourced by information you provide. But then when the roll-up here is actually based on the structure that it's built. And so once the equation's in place, now the LM can check itself using those equations, using deterministic systems, right? So the LM is not doing math at each step, it's creating the equations. And then if those error, you can check that yourself. And then once the structure is set up, then you can modify it at your heart's content. So the key here is that we're not wanting to build documents, we want to build structured data. And that's the kind of main thing that we're focused on in DaVinci. And so we have a whole set of things we can build, the parts, the requirements, actions, and so on. If we head back to our parts creation for the SLS, we're still working on that. So for those of you who have logged on, have you successfully started a task? Everything working so far? Anyone completed a task so far?
I have an entire requirements tree for a software factory that has SBOM and SLSA.
Cool. All right.
It's very cool. Yeah.
All right. Anyone else have a task that started?
Yeah.
Okay, what'd you working on?
I gave it a data sheet and a user manual for a commercial LiDAR unit and asked it to make me a part.
Okay, cool. So another fun thing is I believe the other model has, this should finish in a moment or so, but
This one
the
or-
SLS model, or sorry, the CubeSat, yeah.
CubeSat,
If you go to like one of the part structures, so one of the big things with these models is if you're putting in reference information, how do you know what it's pulling from? That is a difficult task, but in general, what you can do is you can ask these models to kind of tell you where it thinks it pulled the information from. And by doing this, you can then track sort of, okay, it's saying it pulled it from here, but then you can go back not only with other agents, but yourself and check, does this information make sense? And so in the case that we've done with DaVinci, whenever you provide it reference information, it'll pull from what page it's at, and then you can click that and it'll obviously pull up the reference information. You can do this with images, structured text, and so if it finds a specific text match, it'll highlight it. If it's a generic page, it won't. But that way you can kind of trace out through this. And again, because this is a structured data set, it's not just text, when you look at these objects, you can form relationships, and the AI can query those relationships in the graph, right? So that's how it can check itself, saying, oh, okay, I built this part. What are the references it uses? I see that it has these reference connections and what pages it's on. So that lets you traverse data, because that is the real power of this, is once you have these complex systems, you're going to lose track eventually of all this stuff in one context window. And so having this in that format where you can kind of traverse and search it, that's where you get a lot more efficiency as these things scale to like 10,000 plus objects.
It's a quick question. You got the RAG, you got the attribution feature. What model is this using? Or can you, some of these applications allow you to drop down and select your own model based on whether you want a code or something else. So what is baked into DaVinci?
That's a great question. So we use two main models here, especially what you're working on right now. We use Claude for most of the primary agent tasks, and we use Gemini for some of the lower level tasks. At the moment, that's not selected, mostly because we choose different models for different tasks based on cost. Also, the amount of tokens we can send per minute, since it's on a public system using our APIs. So there's a certain limitation we have there when we scale this. When we deploy this with companies, that's where we can architect that in the server. So we are technically agnostic to that. We kind of have categories of models that we prefer, and then you can kind of slot them out for different sets of tasks on the back end.
You're deploying it on company hardware, or you host it in the cloud?
We usually do cloud. You can run servers and systems, of course. The actual agent orchestration, this front-end system that's web sent, that's not a big compute cost at all. But obviously, the endpoints, you're going to want to have those larger models. And that's mostly because if you want to use these models in design tasks like creating a whole parts tree, right, those you're going to really want the frontier intelligence to get good results. Those have the best, I'll say knowledge as much as what LLM's knowledge means, but they have more multidisciplinary information that makes them much more capable. Now, once you've built a structured set of information like this, you do have the option of using more local models, smaller models, because now they have a rich source of information they can search and query effectively. Right, so there you might imagine building a whole structured model, and then let's say in deployment, maybe on a maintenance line or something, you can have operators be using this model with like a local LLM, kind of saying, hey, where does this part go? Tell me the trace of where this connector is. If I have a set of risks, what are the risks that we might run into based on the model? So I guess we can check back in and see if the parts tree has finished. It's still building.
Still cooking.
We can start up the other example here to see if that goes.
Yeah.
It's probably making a pretty big tree, but
It decided on itself to do depth 3, so it's
okay,
doing
that'll
lot of
take a
layers.
moment. So it's going to create a depth 3 hierarchy of parts. The way a lot of these tools that we have, the instruction sets sort of define a scope of like, this is kind of how much you need to build, here's the high level instructions, and then there are different subsets of things like connect the interfaces together or not, and that'll choose sort of different pathways of logic that it can execute.
So is the idea behind your platform, you give it to a science and engineering team, and whatever it is they're working on, if it's LSB and communications with SATCOM, if it's integrated photonics, they load their data sets and then use your platform.
Yes, yes. So the idea is that that common system we have of parts and requirements is fairly general. And what you need to do is basically define what's the part taxonomy. What's the part trees? What's the requirements you have? And so this agent has system engineering sort of approach to problems. And then with that framework, it can plug in the information that's specific. And then it can build things. So we're going to also do another project. So we have 2 different projects going. So we'll start this up. Here we have a schedule for this conference, or the symposium. And we're going to ask it to look through that and create entities from that. So this is more of a business case, right? So we have a bunch of different people that exist. We want to map out those people and then create basically an entity structure so that maybe in the future, if we want to go back and figure out who to contact or people we have met at the conference to follow up with, we can build a structured model. And so then your business development person can ask a query of like, hey, who have we last contacted? Who are the people we met at this conference? You can answer questions like that. So a lot of times we think of when building system models, that's an engineering problem, right? That's only for engineers building complex systems. But I'd argue that it's much more general now because it used to be that required specialty tools, but these models can be built very easily, right? I think folks here have already built different models, started different projects. We're building ones right now. You can model almost anything. You can model your organization. You can model the people you're interacting with. And that structured data, I think, is a lot more powerful than the documents that we work with on a regular basis. So we're going to get that task started up. Hopefully one day the crawler will finish, but it's building quite a bit. Are there any questions you have so far? What you're seeing? Yeah.
So we're dealing with a lot of structured data. What about the transitioning over to the behavioral side, as far as like interactions between the objects?
Yeah, so let's pull up the CubeSat model. We can kind of explore that a bit. So if you look at the block diagram view for the parts, we'll start with part relationships. So we can do a couple different things. So one, go to the relationships, thanks Ian. So this is one example of more abstract relationships between parts. So here we have power subsystem, and it has different kinds of relationships. So in the project settings, we have a list of relationships that exist. You can add to that. And the AI can look at this and say, hey, we have power connections between these thermal. These are pretty abstract, but they're enough to kind of structure out, okay, these things matter to these parts, but these other parts maybe don't matter in this way to these other things. From that, you can then build even detailed stuff with like port interfaces. So if we go to the ports view, you can get down to arbitrary level of detail. So here, each part has a port. Ports indicate some way of information to flow. Think of it as like a hole in a pipe that takes water in, or it could be an electrical pin. And so here we have like a more abstract power connection. We also have more detailed models of like a connector housing with sub-pins. And so the AI can create these structures. You can navigate them here. And these are all different data objects that form up in that index.
How detailed of schematics can it generate?
In arbitrary level, like in the sense that you can nest the parts and keep going down.
Put the correct thing for a resistor or something like that, though.
At this level, like you could make a part a resistor. I'll say in our development roadmap, we are interested in taking this somewhat more abstract framework and then mapping that to like schematic code. So that is definitely a next step. But in theory, like these ports here, this is almost one-to-one with a schematic, but it doesn't have maybe all the resistor symbols and that kind of approach. But certainly if you think about an interface, like definitions, right, this would probably be far better than tables in some Word document that you have.
Are you seeing your customers use it for MOSA compliance, the modular open system approach for systems of systems and all of that?
That isn't something that we have explicitly had customers go into yet because a lot of this is still in the ideation phase, right? They're using this for creating proposals for one-man teams very quickly getting things to people higher up. That's where a lot of our current users are at. However, when it comes to MOSA, that's something that I've run into in industry a lot because that's like the thing that people are worried about, creating these black boxes, defining interfaces, and then having it so you can, that vendor's being bad, rip it out, put in a new vendor, right? So that is something that we are aware of and that we are going to try and design towards and make sure that people can do that. Also, it just comes down to a methodology of modeling, right? We think that we are open enough that people can model in that way. It just needs to, we need to make sure that that is going to be a successful endeavor. So when people do get to that point, we want to be able to work with them.
Yeah, and I think one thing you can also do is like, you can set personas and requirements to sort of guide the design. So here you can do any direction you want, but if you imagine most of those implying certain constraints on like, you got to use these common interface protocols or whatever, put it in there as information, right? That's your design objective. You must use those things. It really, I think, maybe this is a hot take, I think the most of the discussion is more of a philosophy of design than it is anything like really new. It's just like, hey, I want to be able to talk to these things. I want to have interchange. But that really requires like requirements and standards. But once you have those, you can throw them in here. So let's see where we're at with any of these other tasks.
Yes.
Well, we're still building parts.
This one is.
Okay, so we have a breakdown of this. This is finished. So this has gone through and started creating these entities. So like parts, you can create the parts equivalent to organizations. So you can create hierarchies of teams. For each of these different entities, you can give them specifications and information. And so again, these attributes are kind of arbitrary. You can do whatever you want. Here we've tasked it to define session numbers and times and so on. And the agent has gone through and like built that tree out, went through the documents, checked it. You could also ask it to go through and review again to make sure it didn't miss anything, any information's out of order. And that was done quickly, right? This is probably faster than it would you reading this and putting it in Excel. And it has the benefit of being in a structured format. So you can now use those relationships between entities. You could model those to be more advanced with how they relate to your team members, like who's responsible for something. You could ask the AI to do that as well. So.
Okay, so question. So
Yeah.
based on what you just did, just to play systems engineer, I would expect to see this to generate basically a product breakdown structure. Here, for example, here's a tree of all the meetings. Here's a tree of all the companies and the people attached just based on what you pulled in. So is that something you can show now
When it
based on
comes,
what you just did?
so when it comes to that, it didn't model the companies as parts. It modeled them as attributes of the people. So this is a very people-forward thing at the moment. Now I can ask the AI, look at all of the attributes for, organization affiliation.
So we'll ask it to do that.
Yeah.
So now we'll say, this is fine, but I actually want to put them under their companies. So we'll go ahead and ask it to look through the attributes, build company structures, and then move those personnel into that. So that's the kind of freedom you have. We'll also show, once that task gets started, we have other things. So this is the core SysML stuff. We've also extended this where you can create like schedules and so on from this, as well as you can write documents that nest that information. And we'll show an example of that in a moment once this task gets sent off. But our goal here is to try to connect the large set of that engineering flow where you're creating a model and you're going to bounce back to other things and make that faster. So we're going to show you some examples of code and documents. If you want to hop over to the CubeSat example and look at the document that it pulled up. So one thing that I think is really fun is the document creation here. So documents have obviously been a legacy thing. We're talking about creating models, but documents are still pretty useful, right? Because they're easy to read. They can put a narrative and a story together. However, you still want to have that linkage between the information you're building. You want to know that when the AI writes a document, like it's not just hallucinating or making something up. The solution that we've built into this is to basically use inter-sentence structure, like word structure hyperlinking. So these gray things you see here, these map to the data objects that exist in the model. So not only do you, if you change a name and a value, those update, you can then go back through and check and say, hey, what was it talking about? And obviously it pulled the correct relevant objects for that. So this does both automatic updating of documents as they evolve, as well as a trust of saying this is how that information maps to things, right? And obviously building this by hand, you'd have to go through and reference this object and reference this, but the AI can do that quickly. And so you get the benefit of that kind of complex structure and that sourcing that you get from MBSE very quickly with an AI system. So legacy things, this and tables, you can still build those things. You still have those in your organization. But I'd argue that the better way to do that moving forward is to base those in structured information, right? One other thing we can do as well, which I think is fun, is simulation. So we know AI systems are pretty good at coding. There's obviously a lot of money, many, many billions put into making them good coders. But doing this in an engineering environment, one of the challenges you have is that you have code environments that run simulations, but you've got to get data from one element of a project, maybe one team into another team to run the simulations. So one thing that we've been experimenting with is we have Python here that can run in the browser environment, but you can actually, on compile of the code, have a direct references to the data objects in your model. So all these attributes here, these pull from the attributes that exist in the part structure. So on compile and run, the wattage that has, the power, that's directly pulled from the power that's in the model. So if you update this and rerun the code, that's going to automatically be in sync. And that code object can create just plots. Here it's creating values and plots. But you could also ask it to push data back into the model. You could say, hey, update these attributes with a new simulation value, save these images and files back into the database so you can then put it into a document, for example. Those are all things you can do once you have an environment that has structured and connected information. So this is a digital thread. This is MBSE. This is, I think, what it means in a more modern context, even though MBSE is modern. But linking all this information and having the agent be able to sit in that database, we believe is like the key part of getting actual value out of this. Because if your workflow is going to be, I'm going to have a chat bot up somewhere, and then I'm going to have like multiple different tools that don't connect to each other, different data silos, you will inevitably hit a brick wall where you're like, okay, that's great, but now I still have to manually move data over. And why doesn't the bot understand what I'm saying? Why doesn't this agent understand it? Well, it has to be connected, right? It has to have the ability to find that information. That information has to be organized. So let the agent do that. Pick a framework where you can put your information in there, and then have that agent build that framework out for you, and then utilize that to build new information, right? To evolve it. I guess we can check in on the other tasks that we have. Are there more questions?
Document generation.
Yeah.
Is it LaTeX on the back end, or like kind of what's going on? Is it writing you a document that you could go in and then edit things manually if you wanted to change styles for like specific solicitation?
You can edit it manually. It's a homebrew system. So we actually, when we started, we thought, well, what if we use LaTeX? But then we realized not everyone's going to like LaTeX. So I use LaTeX a lot as a physicist. But so we opted to move forward with a kind of word style, which sees what you get approach. So it has setups of blocks that can have different types, like headers and paragraphs and tables. So it gets like 70%, 80% of what Word has. It won't have all the bells and whistles, but it gets pretty close. And you can always send that to Word afterwards to make any real final polishing touches in like the visual aesthetic. But
So the workflow, if you were generating a proposal, might be everything's linked together and you get a draft of your proposal and then you port it out to whatever document system you would use to generate.
yes,
the final.
you can do that. I'd say for an SBIR, you got all the style you need in there. For maybe like a pioneer proposal in NASA or something that needs fancy graphics, you'll have a team that's going to invest some time into that. Although we're working on improving that stuff in the future. So how's it done on the Taskin?
It's still churning on.
It's still
the
churning
SL
on that?
Taskin, yeah.
Okay. But it started to build the organizations, which is nice.
Yeah, it's done.
Okay.
It's done building the organizations. So yeah, we have a bunch of organizations here from a bunch of different companies that presented. Razorfish, saw University of Alabama here.
Cool. So now we could
Yeah.
ask it to move like
yeah.
all of the individuals over.
Yeah, let's see.
And that's kind of typical workflows that we use, right? So you can, sometimes it'll one-shot these pretty well with like a build parts tool and a reference document, but then you're going to inevitably have to modify it and evolve it. So you can kind of chat with it, split up tasks into kind of measurable things, and then move it through that. But even then, right, this is still like way faster than navigating that Excel kind of sheet, right? Because you have these, you can take the advantage of having these conceptual hierarchies and other things that I think you don't have in other tools. And the AI can navigate that effectively for you. So in terms of the larger ecosystem and kind of where we hope to go with this, we also have the ability to obviously use MCP servers. So if you have an MCP server for your system's model context protocol, that can be exposed to the agent as a set of tools. This agent sees a bunch of toolboxes that have different kinds of things it can do, and opens and closes them, mostly to manage context at the moment. So you can imagine adding any number of custom toolboxes. Those toolboxes could talk to other agents, other tools, APIs. We also have a toolbox system internally. I think that, yeah, is here for like weather. So this is an example of weather, api.gov ping that will get alerts and forecast. And so with this active, this then pushes it to the context of the agent, and we can ask it questions like, what's the weather, here is somewhere, and it'll ping that, pull the data back, and then it'll be put back into the agent's context. So within that API system, obviously you can extend that to maybe query a parts database, query DigiKey to find electronics, query the archive to find physics papers on research, right? You can do anything. We also have a web search API that we kind of as a homebrew system just using Google search. Fun note, we found that Claude and other models have some web search features that are kind of part of their model system, but they have a weird caching system with websites that doesn't always update. So it was a little bit more effective to use our own system with Google. But yeah, so here we got the forecast data for here. That, I think, is the next step that we're going with this. We've put a lot of effort into building that kind of intercommunication with a system model. But the next step really is to communicate with larger sets of tools. So your work tasking tools, especially model and simulation. That's a big, I think, frontier here in the sense that when we started working on this 3 years ago, agents weren't even a thing that people talked about. And we were building what I think was effectively an agent at the time. But now that this is kind of in the domain of people, a lot of companies have pivoted their discussions to, all right, we're a workflow tool organization. Now we're an agentic company, right? So those now, I think, puts an ecosystem out where there's going to be more agent-to-agent communication. And so I think being able to merge these platforms where one agent will be building a system model, then it can call an agent that's doing a CAD development or running simulations. That's going to be the next kind of step with this kind of thing. But definitely that knowledge management is still going to be really important. And we certainly hope that a tool like this and other ones that I'm sure will come up, building structured informations from your stuff, not just creating a vectorized list of documents. That's not going to be enough. You really need to create better data structures, and you can do that with these agents. I think we've hopefully demonstrated that in this kind of technology. Okay, well, this will continue to work on tasks. What's some more questions? So I'd love to engage more about what are some challenges you guys are facing and how tools like this and agents in general can help solve them.
What's it cost?
So a license for this is like anywhere from 500 to 1,000 per user, 1,000 for like a seat-based license.
Per year?
Per month.
1,000 per
Yes.
user per-
Yeah, for 1,000 for like a seat-based license, so that can be floating. 500 for individuals. That's for like enterprise. For just personal use, that's like a $20 or $200, depending on the amount of credits you're going to want to use. So that's the costing we have right now, which is pretty standard.
You said that's per month?
Yeah. Mhm. So
You said 20 per user?
that's for like an individual, just
Yeah.
playing around on their own. That will only give you a certain amount. That includes the compute cost that has a limited amount of credits that you'll have access
I
to.
don't want to press you too hard, but why would I use this over Abacus AI that has a almost identical, maybe not as fine-tuned for engineering, but same platform, like same backend, selects the models, build your deep agent, it's $20 a month.
Because it's not actually going to do all of this, right? Like it's not creating a model of things per se. It might be building different sets of like code or other information. And by the way, you certainly can build these yourself if you invest the time to create these systems. Obviously, from the business perspective here, we're providing the case that we have this front end, we have this database that's custom that builds this out. And then we're obviously tuned the agents to be effective at working within that. But certainly, if you have very custom applications, I mean, that's a trade-off you have to make. Yeah.
So for traditional MBSE tools like Cameo, that's a big thing.
Yeah.
Certainly in Huntsville.
Certainly.
So can you suck in a model from Cameo System LV2 and play with it and then export it back?
So comment on that. Who has created a System LV2 model in Cameo right now?
Yeah.
So,
Yeah, so that's
that's
minor detail.
yes.
Because
In
they
terms
just
of
came out with V2 like
Right.
correct,
ago?
yeah.
Yeah.
So in terms of like System LV1 models, right, 1.x,
Right.
what have you, we are able to ingest. So it's very diagram based, right? Because the LLMs are able to read these diagrams, we're able to ingest all of those independently and then create models based on that. We are currently working on a direct SysML 1.x22 conversion within DaVinci.
I think the interesting part is that even in Cozy has said this, right, that the conversion from 1.x to 2 is not going to be deterministic, right? It's not going to be a simple mapping one-to-one. So that basically means for us is like, oh, okay, that's free reign to actually do what we knew had to be done, which was have an AI look at this and actually try to transform that in an intelligent manner. And so that's going to be the approach that we're going to take. Some things will map, but most of it won't. And so it's going to have to create its transformation from that texture, that like XML basically into the 2.0. So.
But what you're doing is V2 compliant? Am I reading that right?
Yes.
Yes, so even though visually it looks different than how the visual syntax is listed in the spec for V2, we have changed that in order for it to be more user-friendly for people that aren't necessarily disciplined systems engineers, because we believe that models are only effective when people actually use them. So we want disciplined engineers to be able to use these models, query them, actually get reasonable information out of them. So we're not going to use all of the necessary like lingo that is within that system or SysML v2, but the back end, all of that textual notation is there, and you can export these as SysML v2.
Yeah.
Yeah, that was my question is, since you guys are bound to the cloud, if we have a model somewhere you can't deploy, can we do our research out here on open stuff and then deploy to that environment, it sounds like?
Yeah, oh, definitely. We've had discussions of that where one workflow we've talked about with like some Army folks is we build a model of like the platform, and then that platform is going to be in a controlled environment where we're not going to have access to all this. So they're going to take that model, put it in there, and then they're going to use a local model to like answer questions. And the design team is going to be using more powerful LLMs. Yeah. And I think the reality I think with SysML 2 is like, AI is here, and so I think the core aspects of that are important, but you also have to focus a lot on what makes the workflow good. And I think when we looked at the textual syntax, we're like, okay, usage and definitions, it's a lot of baggage, a lot of cognitive baggage for people. So like we don't use that right now. We might in the future add some of that capability, but that's not a big focus. But the parts, the actions flow, all of that stuff, that's pretty bread and butter. It's pretty easy to understand, both for us and the AI. So that's what we've targeted as that kind of core system elements, but some of the edge cases of it, some of the libraries for sure, like we're not going to immediately support because, to be frank, I don't know if anyone's going to be using those right now. But it's a very good question. More questions, more thoughts?
What if you needed to share the model with someone who doesn't need write access, so need to share it to a stakeholder?
Yeah, so that is, we can do that. So actually this has a collaborative interface, so you can like share it with people. We have the ability, we're rolling this out soon, where you can have a read-only permission to share with people. You can internally like lock objects. This will actually prevent the AI from editing things, so we have some of that, but the plan will be is to have that set up. It's not available like at this moment, but that is something that some of our customers have asked for that we can do. So there'll be some set of licenses you'll have for like people using it, but then you'll have like read-only or view-only access to any number of people in the team that want to access it. So how's, we can check on other projects who we're at. Okay, we finished the block part structure. How have the projects you guys have worked on? Any more updates there?
Right now it is stuck on building a behavior model.
Okay,
Like that.
cool.
Okay, so yeah, it built 148 or 49 parts with 295 attributes. So it took what we consider to be a long time doing that, right? But at the same time, how long would that have taken by hand? Right?
Yeah.
And that's what you're competing against.
And so that's pretty cool. So we got the main 2 boosters, vehicle adapter, ICPS. So it's got a lot of the main elements we need. I imagine the core stage owns like all tanks, and so we can see all the structures it built. Yeah, I mean the scale of this is like remarkably fast, right? And I think, I believe in the next year, right? I mean, we're going to be talking about getting to a PDR status in projects in like a month, right? If you have all the data, you have compute for simulations, and you can connect those simulation environments together. That to me seems readily possible. Now, it's not necessarily going to be cheap from a compute sense, because eventually these things need to start running simulations, and simulations can take time. But I think moving to a full agent architecture that can run those things, potentially distributed agents, right? That's the only way we're going to get to that truly rapid pace of design. And I think we already basically have the technologies for that. It's a matter of building the stack. And there's already enough investment in LLMs today that they're already competent enough, and then all the improvements we're going to get in the next few years will be well enough for us to accomplish those kinds of goals, especially as people who are designing and operating these things. I'll also mention, we put in a Git system here, so one thing that's pretty fun is all these objects in the database, these are Git tracked, not necessarily on like a line-by-line level, but every field value, all these objects, the blocks in the documents, they're tracked, so you can create branches, you can merge, all that kind of stuff. So both your documents, the part structures, all of that follows a Git-like system with commits and branches. And we don't have it now because we just rolled out the Git stuff, but eventually we'll have the AI be able to go through the Git branches and be able to ask questions like, hey, what happened on this branch? What are all the commits? Do delta tracking and searching. That's some new features we're working on now. But that's where we feel the change management part will come into play, because Git's already a pretty good system for that. And once we get that online, I think that'll be really, really awesome to see it build those histories of events.
We're also able to include other projects. So if you have just a requirements document or model that's based on a standard that is not really going to change, you can model that one time and then put it into all future projects that need those requirements. So you don't have to continue rebuilding over and over.
Yeah. So like the package includes stuff and imports, that's same kind of mapping there. Yeah, so more questions?
So a lot of this stuff is mainly physical. So we use Cameo primarily for the software factory type of stuff. So
Okay.
have y'all dabbled in any of that in terms of like sequence diagrams or?
Yeah, we can get a behavior action started. We can try something simple, so it won't take too long to build. Oh yeah, we have a launch sequence. Yeah, we can take a look at that.
Here.
So we've taken an approach here. It uses a kind of mix between the Python syntax and the SysML framework of like flow statements and like branches. And so this writes basically a pseudocode, which is the sequence, the activity flow. And then we render that in these diagrams for seeing that. So yeah, I could write this. I can edit it just like code. And so you can create flow statements. This one doesn't have, I think, any flow statements. But if it had flow statements, you can render it as a sequence view. And so it actually kind of merges the two. So as the SysML2 textual syntax has it, you kind of just write those things out. And it's a little more fluid rather than building two different diagrams. You kind of swap between them. One thing we've also approached, which I think is important as a kind of philosophy of modeling, we're not really diagram focused. I think that's a mistake. Like when you have to think about your model as just being one diagram of this and diagram of this. They're very much more object centric, and you can choose an object, choose a depth, and then look through different views where you can express it as a tree diagram, express it as a block diagram, express it as an activity diagram. Because I think the goal here is that you're going to have large complexity of these systems, but you really want to manage mostly these fundamental parameters and their relationships, and this rendering of it should always be more deterministic rather than the thing in and of itself, right? That complexity should happen, and then you use those views to understand it rather than force through diagram visual clarity to corrupt the reality of what's actually happening, which is, I think, the philosophy we've taken. More questions? Yeah.
So if there was an organization that had a requirement that for any models that are being used, it has to be an internally managed, model, like you had your own API. Is that something where if you were setting up this system for an organization, you could, specify an internal endpoint instead of whatever is currently in use?
You mean that for like the data storage, like where this information is, or you talk about that from the AI side?
LLM that's supporting the agents in them.
Oh, yeah. I mean, you could swap out any kind of models you want, any kind of endpoints. I mean, we have a NASA deployment we set up, and so those ping GovCloud controlled endpoints. Yeah. And I think typically for an organization, you're going to have access to all of your keys with all the providers that you've set up in your cloud, and eventually, when open source models get better, those will start to take share of some of that, hopefully. That'll all be controlled by your organization. Yeah. Yeah. And I think, I'll say the rate this space is moving, I think there'll always be the frontier models, but I do suspect in a few years that, we don't know the cap of how well these things can actually perform, and especially efficiencies. I think we're still seeing these open source models have some good breakthroughs. So compute will always be in demand, but I do think that there's still plenty of room for this space to evolve. And I would suspect that there'll be more options available in the coming years for that kind of stuff.
So you mentioned GovCloud. Are you guys able to deploy to like GCC High and all that sort of stuff?
Yes, I think obviously at ATO may be different questions depending on what branch you're in, but we certainly can. The main limitation, of course, is what models you have access to. I'd say the models that are available in those are sufficient. They're not as good as maybe what you saw here, but they can work. They're like a year behind kind of thing. The other problem can be is the token limits they have are also worse, so things will be slower. These are a little bit slow today because we're kind of rate limiting a bit for this demo, but that's one limitation. But it can function, and we have had it operating for folks. Yeah.
So I have a question. If you're running a university program in computer science and artificial intelligence, and you've got, we'll just make up a number here, 1,000 students. I like to do one-digit arithmetic. And you're spending $30 a month to get a tool, access to the students. You can't afford that. And so how do you do this in a university environment? How do you get access to a tool? For instance, I got an email, just a minute, I got an email just a little while ago from the New York Times.
Yeah.
Can you see what it says? It says code with Claude.
Yeah.
I mean, that's a New York Times article this afternoon, okay? So how do I do this at a university? How do I make it accessible to students? We don't have a budget for that kind of stuff.
I think there's a couple things. I mean, I guess one, what do you want the students to do with this, right? I think, for us, there'll be a different pricing for like educational use. Obviously, from a like other business case, like larger companies, that's going to be the number I just quoted, right? That like enterprise seat level. If you're looking at individual students, it depends on what they want to do, right? So for large research projects, you can have much cheaper seat-based licensing for certain things. I think the Claude Code there, I mean, tuition costs are well beyond, right, with the coding costs you're going to be spending for that. So depends. I mean, what's the scale of project you're dealing with?
Well, I don't know. I'd have to think about the scale of projects, but we want to we want them to use the tool effectively.
Yeah, I know the school that I went to had licenses for MATLAB, for SolidWorks. I know that UAH now has, it's like a Cameo Center of Excellence or something like that, right?
They're spending an enormous amount of money on software licenses.
Yeah, like that money's already getting spent.
Yeah. And most of the time it's seat-based. So like when you're doing a research project using these specialized tools, like ANSYS is like, hundreds of thousands of dollars just for like a seat, right? I'm not saying that that's good, but like most of the time, a few amount of individuals are using some of those specialized tools. Now I think the world we're moving to is that you'll be able to code a lot more of the simpler things you're doing. And I don't think that a student necessarily has to use a tool like this, but they could. It just depends on what you want to do, right? If you just want to use coding environments, the costs of like Claude stuff aren't necessarily that high compared to other softwares. And it's probably well within the budget that the university would have for that, depending on how they spend their money.
Yeah, I think he created something very useful for specialized teams. You have FedRAMP documentation. So you said this is FedRAMP compliant.
We can
The
deploy.
older models, like you had
Yeah.
an ATO, you went through through that process?
We had deployed at NASA at IL-5 instance, so it can be done. We don't have ATO with like Department of War.
Got it. So asking for a friend, can, if they can they create elements, links, and Cameo with IDs and traceability?
You can create arbitrary relationships between parts and link them together. So I think the answer to that would be yes. Now, if you mean like with Cameo models themselves, is that the other aspect of that?
I think so. You'd have to give them a demo.
Sure. I think right now we don't have the ability to talk to a Cameo model, and like at the moment the only data exchange would be either through the API, which we haven't written on. I'm not even sure if they have a good API or not. So I think no, but in principle, yes, right? I mean, we're obviously going to work on a way to import legacy models, and if there's an interchange format that's common, like if you can export a table of things, then obviously that we can interact with. I'll be blunt and say we are looking to replace Cameo, of course, so we don't have a strong desire to try to integrate with them because it's probably going to slow us down. But we definitely recognize the need for there's a lot of legacy models, and we're not going to want to leave any of that data behind. Yeah.
So what kind of merge support do you have in case a get merge goes wildly wrong?
When you merge, it's like a new commit in that stack, and what happens in a merge is that any changes that occur will show up in the model as like conflicts in those objects, and you'll have to resolve them. But you can always undo back to the last like commit prior to that. And then you can't make another merge until you've resolved any conflicts that have occurred in those things.
So do you do something to ensure that just the base level, I'm assuming it's a text representation that you're using?
It's a database, so this is not textual syntax behind the scenes.
But do you do something to ensure that the raw outcome of the merge is going to be a valid model?
Yes, in the sense that it won't corrupt like the data fields from their formats that are validated. But you can certainly break a model if you merge a broken aspect to it, or if you have fully rebuilt something that causes these chains to be removed, but then decide to keep those old chains, that won't work. But things like objects getting deleted, but then showing up in other models, those just won't happen due to the way the database is structured. But you can break like relationships potentially depending on how you merge if you're not like accepting incoming or so on. Yeah, and then you for each conflict you will have to resolve what that is. And so you can do that on like a block by block basis in documents. You do this on a field by field basis. Additions and removals don't have conflicts because they can't in this particular case because it's not textual syntax behind the scenes. Like each of these objects live in a database, and so there's no way to have merge conflicts with those kind of deletions, which certainly helps. But attribute fields might get kind of wonky when your equations need to be reassessed because things have changed. But you can ask the AI to go through and do that. But it is it's an interesting blend that we've just rolled out recently. I'm pretty excited about using it internally, and hopefully others will enjoy that.
Could you talk? I saw like a little screen clip video of DaVinci doing something with solid modeling, and I was wondering if you could talk more about that. And does it use like a programmatic definition like OpenSCAD does, or is like what's that work?
Yes. So sadly, I can't show you it here. It's not in the public deployment we have. But I will talk about it. So we're in a process of research for that. It's part of our funding we have with the Department of War is to develop that. We're approaching three kind of avenues with that. So the one is a programmatic case, like SCAD has. There's definitely, we have seen progress in the ability for it to write operations that create structures like flanges, brackets, and so on. If you've seen Zoo at all, same kind of approach as that. That does complex systems that are built with that, like really complex brackets and so on, it does tend to fail and have issues resolving. The other element we've explored is creating assemblies, where we take a whole different approach where we use the LLM's ability to kind of look at coordinate systems and understand that. That has shown promise in basically creating regions of space, like I'm gonna put this here, and like minimizing overlaps. It's actually been pretty good. And so we're looking to do those two areas for more of a ground-up, top-down approach. The third area that we're also very interested in is connecting to generative solvers. So some work we did with at Goddard, they have a team that does generative structures, and that uses pretty traditional solvers. But having the LLM basically look at the part structure and be like, all right, I have these two different pieces. Let me think about just roughly, they're going to be positioned on top of each other. Here's bolt locations that I want to target, and then send that into a physics solver effectively, more traditional ML approach. Get back this organic bracket, and then throw it back in the assembly. So I believe it's going to be a mix of all of those, probably heavier on the bounding regions with that's like machine learning solving of those brackets initially, because you can get really complex, efficient things, rather than the LLM writing instructions. But we're kind of playing out all three to see how it goes. It's one of those spaces where I guess the dimensionality effectively explodes, and so it's going to be a lot harder than creating these parent-child structures, but I think we can make some interesting progression there for sure.
So is this like a Sipper type thing you're building this thing?
What is
Most of the
on
basis
that?
for this we bootstrapped ourselves. We are under a directive phase 2 right now to mature this, but so some of the features here have been built under that, but a lot of it we built kind of in our own in the garage. Yeah.
Was NASA a component?
NASA was one of our first customers. So we actually didn't get any SBIR funding from them. They just were like, this is cool, we want to try it out. So we have a kind of evaluation going there. And they're buying licenses and using it. So their program science people have been using it where they're like, I want to study the sun, so let me have this help design like the part structure for the satellite and then use that to ideate on science requirements and get that kind of refined. And so they use an approach where they have like Claude and they're going to ask to like really high level ideation. They throw that kind of result into DaVinci where they go to the next step of like, this is the requirements list, this is the part structure, this is the first draft of the proposal. And then they take that to their mechanical engineers and do that kind of stuff. So that's pretty new. It's not everyone, it's certain groups at Goddard mostly have been pioneering that, but I think we're planning to expand that approach to different areas because, I mean, they have a constraint where they don't have money and they don't have time. So a tool like this is really, really important. Okay, more questions? Happy to keep chatting. I don't know if there's any more stuff we've built or you want to keep messing with, Ian.
I'm having it build states right now.
Okay, cool.
So it will build states for various things like deployed, in transit, etc. And
Yeah.
it'll have attributes that will vary over time based on the state that you're in. So it allows you to see kind of that over time sweep of how an attribute would change.
Yes.
I'll ask one more question. If I took Claude, how long would it take me to use Claude to write a Claude?
Well, when you say write a Claude, what do you mean?
Well, I'm just going to just have it write the tool.
Well, Claude is it's an LLM, right? So in some ways, no, Claude will never be able to write Claude because you have to train Claude on like sets of information. If you want to write the Claude app itself, that would take you a day. If you want to write something like this, I mean, it's going to take you like a while, right? I don't know how long will vary, month to month based on the models, but I mean, we use Claude to write this, yes, but it's taken us years to get to this point. So can you do it? Sure. I believe anyone can do anything if they put their mind to it. So, I think the answer is sort of yes, but it depends on how much money and time. Now, building an LLM is obviously different. It's a much different problem.
So you gotta know exactly what you want.
Yes. And I think this is one of the things that I'm quite excited about in general with AI is that as the barrier of creating things drops, before you look at a problem, you're like, okay, I want to do this mission. I got to figure out what I want to do, but I also got to spend all this time to even figure that out, right? I got to write all these scripts, got to do all this analysis. Well, all that script writing analysis is now kind of gone, right? It's really fast. Now you're left with the thing that was always the most important. What the hell do I want to do? What's the value in what I'm doing? What's important? And so I hope that organizations and people in the world can take this moment to say, what is actually important about what we're doing? Now we can do whatever we want. So let's do what we want to do. But now we can also build the tools to better understand that value as well. But the emphasis will still be there. And I think the real difference between those that will hopefully succeed in these things and those that won't are the ones that understand what they want and understand how to measure that value. Because the difference, like AI slop isn't really a thing, in my opinion. People make slop all the time. It's just when you give bad instructions, you get bad stuff out, sure, that was always going to happen, right? It's just, so far to this point, the ability for people to do that's been hindered. Now we're seeing what really happens when people don't have direction, they just create slop. So you still have to be guided. You still have to understand what's important. You have to have feedback loops with that value. And so one thing like the philosophy here that is important is the fact that these attributes roll up with math equations, that's feedback loop, right? The fact that you can write code to start maybe driving what some of these values are, that's feedback loops the AI can use. And hopefully when we have more CAD online, more analysis tools, those are feedback loops. And the only way the agents can ever get to a solution that works is if they have feedback, the same way that we'd require feedback on the stuff we do. And I think that's still an open area. And I think if you're going out and building these agents, those feedback loops are the most important thing when you think about long-term stability towards a goal. It needs to be able to check itself and understand if it's on course or not. And that can be challenging for certain problems. And I think when you think about workflows, that ability to check that's good. I mean, SpaceX, their feedback loop is to build something immediately and throw it out there in real life and see what happens, right? That's an expensive feedback loop, but it's very valuable if you can afford it. Other people do simulation, but simulation may not be a good feedback loop because simulations can be flawed. But cheaper, sometimes, maybe not. Right? How many people do you have to make a simulation? So those problems will still exist. Yeah.
So you have the ability for this thing to reach out. Is there a way for, I have a Claude Code instance, something like that, for me to reach into the model? And it kind of query and correct itself.
We are working on that. Okay. So we want that. So we internally want to create bots between our chat systems to we have our Slack or Discord or whatever and talk to this.
Well,
and
we need beta testers.
Yeah, and we want other people to use other tools to be able to get information out, because we definitely, if this becomes siloed, that would defeat the point of what we're trying to do, right? So yes, and we are working on a way to have an API that can query the same kind of query tools the agent uses, other agents can use. And so hopefully there you can create a standards document in here and then have some other tool, your own chat bot for your company, right? Be able to query that information.
So do you have, when you mention feedback loops, do you have mechanisms that are going in and looking at your requirements, for example, to see, hey, this is not physically realizable, or this requirement's untestable, hey, this is NP complete, or maybe it's undecidable?
So you can put on, if we want to put the reviewer mode on, I don't know if we have a task running. So we have different personas, and one of them we've baked in as a reviewer, and it has the boilerplate of be critical, look through this. And that kind of agent go through and create checklists of all right, based on my assessment, I think these things are suspect. Here's a list of recommendations. So the answer is kind of yes, and I think the solution there will be having multiple agents. Also really important is if you have the ability to put information in, maybe a lessons learned database, right? Like an MCP server that you could query and understand in the past we've had these failures, have the agent pull that in during the review. That would be really important, right? Because there are still plenty of information that these models will not have about maybe very domain-specific problems that you have faced in your organization, right? So hooking that up, creating a model maybe of part systems and how they failed, having a collection of those different system models for those past failures, be more rigorous than just documents, and have agents be able to talk to those other projects, right? That I think would be really powerful in the future, but definitely at minimum having just those documents be accessible so that when the review is not just whatever the models know, but that very specific domain stuff that they won't know.
So you're going to build default connectors that you can just hook up to other systems.
Yes, we'll definitely we'll have an API that you can query with, because once the database is up on your server, other agents could query. And then we don't have this right now. You can import projects, but one thing we're going to develop is the ability to query other DaVinci projects from DaVinci itself as well. That's going to be coming very soon. But we're 5 people, so we move as fast as AI will allow us. And honestly, the testing factor is probably the biggest issue we run into right now. We spend most of our time fixing bugs. that are in the UX, right? Fixing agents not quite working well, and that takes time because we haven't fully automated that process, although we're working to do that.
You said you're 5 people. I'd love to know how'd the team get together? How'd you start? Why do you care about this?
Yeah, so we've known each other for like 10 years. Same for our other founders like Chris and Steve, and we've hired a new person over the last was it
3 months.
3 months ago. So we worked on projects in undergrad and graduate together, so we were a very close kind of group. For myself personally, as I kind of said in the opening, I was doing CubeSat designs. I was studying gamma ray bursts, and you have to fly instruments in space to measure these things. They emit gamma rays. And the only way to do that is to put it in space, so I need to put it on a spacecraft. I got to put that on a rocket, and that's already millions of dollars. So you have to put in a lot of effort to make a concept that works. You've got to propose to people who have the money, like NASA. And so I was even though I wanted to do physics, I was stuck in that process of writing budgets and coordinating design teams. And so I was like, well, why can't we do this better? And I realized the tools were a big barrier to that. And I think in a larger perspective, as a physicist, I think theoretical physics is good, but you have to observe the world to really make progress to understand how things go. That means you got to build instruments, you got to put them in space, you got to build colliders. That's expensive. Why is it expensive, right? Well, mostly because we have to spend years building things, let alone even physically doing it. So why don't we at least solve this? And when GPT came out, I realized this can at least solve a chunk of that problem, right? Which is that human design element. So if we can reduce that cost, then the next question will be is how to reduce the physical assembly of those things. That's more maybe robotics. But so if I can make a contribution to that, I think that would move forward a lot of things, including the research that I wanted to do. So.
You guys went all in, did a startup, quit your jobs, all that.
Well, I guess I was in PhD, so I didn't really have a real job. So yeah.
You did.
Everybody else just watching you.
That's what I did. Yeah, I waited until the SBIR came in, and it's like, there you go.
Yeah. So I think though it's like, yeah, these models have certainly helped. I was not amazing at writing like this JavaScript. You know, I hadn't really written JavaScript 3 years ago, and so I've learned a lot doing it. But these models have also enabled us to scale in ways that I wouldn't have been able to do 5 years ago. And I think that's true for all of us. But it's only going to be true of the teams that actually try. And I think, there's a lot of people now that have hesitancy to do it, for some for good reasons, but I think a lot of it bad reasons. Like you can do things. And I think there's a fear of, well, it's going to be difficult or it's going to be that. And it might be, but I mean, these tools can really do a lot more than you think sometimes, especially for folks who haven't been involved in it. I'm sure a lot of you are already in it, and I'm preaching to the choir, but for those that haven't, I don't think they fully understand what this can do. And a lot of times it's because it's put in environments where you're not connecting the data like this can do, right? And so if you're just dealing with a bunch of documents, yeah, it's going to have some trouble connecting all the dots because it's doing a task that's hard, and what you're asked to do may not even be clear. But if you're clear on it and you have a strong data environment, you can see what can happen, right? It can be much more focused. It can be much more productive. And when you're coding, for those coding with these models, you see it, right? You see it's very clear. But when you get to these design parts, it becomes less clear. Business development's become less clear. And I think it's because the processes and the way you're interacting with data is often flawed. But I think if you take structured approaches, you leverage a lot of the things that work in coding environments in that domain, which you can, you'll be able to reap the same reward that I think the coding folks on.
So do you use DaVinci for your DaVinci development, in Dogfoot?
Almost. So
Very close.
because we had a desktop app, we went to a web app because it was easier to deploy to people. It's a lot easier when a government person can go to a website than have to install something on their machine. So that's why we went to the web app. But the web app can't run the full code. So we are experimenting on whether there's some things we can do to make that happen. But the moment we do, yes, we will fully vertically integrate. But business-wise, we do all our business tracking, company information, proposal writing. We do that using DaVinci. So, yeah. Okay, that I guess finishes a lot of it. Unfortunately, the developments here were a little bit slower than I liked, but hopefully some of you guys got to build stuff as well with the tool. You can go online and try it yourself for free for a bit. You'll get some compute credits you can play with, and I encourage you to do that and see how it works and what you like and what you don't like. Do tell us what you like and don't like. we're trying to improve this, and we're actively deploying with folks, and so that has been a big learning experience to understand what they want to do with it. Obviously, we have our vision for things we've worked on, but you guys have lots of sets of problems that I've never had to work with, and that's really valuable to understand how to make stuff like this better. So looking for feedback, looking for engagement.
Do you have a slide with your contact information, your cards or something?
I have cards, so you can come to me. I will hand you cards.
Yes.
If I could just pull up the website.
You can pull up the
right
website,
now.
yeah. So we have a website online. We're also, I'd say we're on the website, but we're not, because none of our information seemed to have gotten transferred into the AI Symposium site. That was nice. But yeah.
That's where I get confused.
Yeah. I sent them a full bio a while ago.
Times.
A few times.
Well, because they're not used to pitching, right?
Yeah. But I'm happy to keep chatting, so I'll just, that's the bulk of the stuff. But if there are more questions, I'm happy to keep talking. Yeah. Thanks.
Thank you.
Appreciate your time.
Yeah, no problem. Glad you guys sticked around for the last session. Thanks for being here.